Alright, so now we're going to talk about whether a compound is ionic or covalently bonded. You've watched the videos talking about ionic bonding and covalent bonding. Now we're going to talk about how you identify whether something is ionically bonded or covalently bonded. Sometimes covalent also is called molecular. Just so you know, these compounds are called molecular compounds. I just call them covalent compounds because they're bonded covalently, and I think that makes more sense than introducing another term. I always try to keep it simple. So basically, in short, this is going to be really straightforward to the point. Ionic compounds, now there's a more complex way to do this involving electronegativity values, and that's just beyond the needs of this class right now, so we're not talking about that. But if you ever see that, there's actually a numerical calculation that can be done to determine where a compound falls on the scale of ionic or covalent. Because then there's several types of covalent molecules as well, based on like the differences in the values. So it's a little more than just this. Now, ionic bonds, pretty simple. These are metals bonded to nonmetals. All right. Covalent compounds are nonmetals bonded to nonmetals. I was looking neat and I goofed up. So, all right. So we've got ionic, metal to nonmetal, covalent, nonmetal to nonmetal. All right, it's pretty simple. And the only challenging thing about this is that you got to be able to identify what's a metal and what's not a metal, right? So to do that, let's go through and take a look. So periodic table again, useful. So in short, we are going to look at this little black stair step line as our. This is sort of where we're going to differentiate. Now remember, we've said this before, but we'll say it again. Everything to the left of this line is a non-metal. So this line here, all right, this line, this whole stair-step line, it's called the metalloid line. Everything to the left of it or to the right of it, we're going to say is a non-metal. So that pretty much means all of this stuff is a non-metal. It's, you know, there's a few things that are metalloids, which have properties of metals and non-metals, but for the simple purposes of this idea, we're just going to keep it like that. All right. There's one exception, of course, though, on the other side. So hydrogen is also a non-metal. All right. It's over on the left side of the table, but remember, hydrogen is also a non-metal. That means everything else, though, not in this side, everything over here is a metal, again, except for hydrogen. So all of this stuff, all the stuff on the bottom of the table. So everything all around there, it's all metals. So like most stuff on the periodic table, most things are metals. You know, we've established that. And pretty much what you're going to do now is just look at compounds and see, do you have two metals, or do you have a metal bonded to a non-metal or non-metal bonded to a non-metal? Now someone always asks, well, what about metals bonded to metals? And that's just called metallic bonding. It's not something we talk about in this class. It's not something you need to like really worry about. They don't really bond as like you're thinking that fall into these categories, so we just don't get into it at all. It's not something you ever need to be concerned about. So let's just keep this straightforward and simple and take a look. So I'm going to show some example compounds, and we're just going to identify whether they're ionic or covalent. So examples. So let's look at something really simple. NaCl, sodium chloride. Sodium is over here. It's a metal. Chlorine is over here. It's a non-metal. When you see that written, that makes this an ionic compound. So you can just write ionic there. All right, that makes it an ionic compound. Look at another one. So it's pretty simple. It's even simpler. Like if the first thing's a metal, it's just an ionic compound. I mean, you know, if you want to keep it really simple, like H2O. All right, H2O. Hydrogen is a non-metal. Established. It's a gas. It's a non-metal. Oxygen is also a non-metal, so that makes this a covalent molecule. I mean, that's pretty much it. I mean, you know, these little subscripts, these little things that are going to be in the formulas, they don't matter to you yet. They will matter very soon. But they don't matter at all right now. You don't need to be concerned about them. You don't need to worry about them. They're just there. They don't affect this at all. Another example, let's look at like PB O2, lead oxide. Lead's obviously a metal. If you look at the table, lead is, it's actually close to the right, but it's still on the left side. It's to the left of the line, so lead's a metal. And then oxygen is obviously a nonmetal. That makes this ionic. One other example, let's look at CH4, methane. So carbon is a nonmetal. Hydrogen is a nonmetal. So, you know, you're like, oh, that's covalent. And that's all you're expected to do today. Just identify whether they're ionic or covalent. The reason we care is that these things are all named completely differently. So like, if it's ionic, there's this whole set of things in terms of like writing these formulas and writing their names. If it's covalent, there's a whole different set of rules. So that's why we need to care about this right now. All right, so that's the basics of this.